Hello, everybody. Good morning, good afternoon, good evening. Happy time zone wherever you are around the world. Feel free to drop in chat. Let us know where you're from. Hello to everyone. I'm Ian Douglas. I'm a senior developer advocate at Postman. And today I'm joined by Melinda, who is also working at Postman, and Julian as well, who works on JSON Schema. We're going to do a round of introductions, and we're going to get into some pretty interesting stuff around what is JSON schema. We're going to talk about some tips and tricks. We're going to talk about testing. We're going to get into the whole history of like, what is JSON? How did that build into a schema? How did that get so darn popular with the APIs that we use these days? So let's start with some introductions. Melinda, why don't you tell us a little bit more about yourself and what you do at Postman?
Sure. So I'm a technical writer, and I work with both Postman's developer relations team and Postman's open technologies team. They're very different teams, but on DevRel, I focus on creating content for the product. Sometimes it's blog posts, sometimes it's videos. I recently did a video tutorial related to this stream called Validate Response Data with JSON Schema. And yeah, I also work with the open technologies folks and have been focusing a bit on JSON Schema lately, which is what led me here.
Awesome. Cool. I did drop the link for Melinda's YouTube video. I was going to share that as part of in case you missed it, but she beat me to it here. So feel free to check out that YouTube link, and we'll definitely be talking about that kind of through the session as we go. And next, Julian, why don't you introduce yourself and tell us a little bit about your background?
Yeah, sure. So I work on Postman's open technology team. I'm a technical lead for API specifications, and I focus primarily, certainly, on JSON schema. I've been involved in JSON schema for quite a long while now. I think almost 12 to 15 years, somewhere around there. It was a hobby for a very long while. I sort of started the JSON schema test suite, which I'll mention a bit more about in a minute. But then over the past, let's say, year or slightly more, I've been quite thankful to have Postman supporting JSON schema amongst other specifications. And so now these days, I'm spending quite a bit more time working on both cross-language tooling for JSON schema, which I'll explain, as well as an implementation that I maintain in Python. So my programming background is as a Python developer. And so I maintain an implementation of JSON schema for Python. So if you've used the implementation called JSON schema, confusingly in Python, that one's mine.
Sweet.
And yeah,
I have used that myself, actually, because I've got a big programming background. I do mainly Python these days. I've been using Python now for, 15 plus years. So yeah, I've had the opportunity to use a lot of libraries over that time. So yeah, JSON schema is actually one that I've used. I didn't know that was you. Good job.
Cool.
How did you get interested in like, oh, I want to focus on this schema thing and like learn all the ins and outs and educate people about it? Like, how did that come to be?
Yeah, I have for that, I think, a very common story for people who work in open source. By which I don't necessarily mean people who get paid to work on open source, just in general. About 15 years ago, I would say I was a beginning programmer trying to write some sort of website whose purpose I completely have forgotten by now. And I was speaking to a friend who was a more senior developer, and I was trying to send some data back and forth between a backend process in Python and a front end. And this developer, his name's Ivan Kozik, so everyone can go check him out. I'll try and drop a link. I think was the one who told me, hey, there's this thing. It just came out a little while ago called JSON Schema. You should go check that out. And being a new programmer, but also quite an opinionated programmer, I looked around at the implementations of JSON Schema at that time, and I actually didn't like any of them. So I said, all right, before I write this website, I should first write an implementation of JSON Schema. And so, of course, to make the rest of the long story short, I don't remember what the website was about anymore, but the implementation stuck around, and people started using it. And I was like, oh, that's cool. I don't know how to maintain open source, but I guess I better figure that out. And so that's been the last 10 or 15 years of my open source career, was maintaining this library that all of a sudden became quite popular.
That's great. Good deal. All right. Well, before we go too much deeper into the content, I'm going to share my screen here, and we're going to do In Case You Missed It. So we like to start all of our live streams with In Case You Missed It. And it's just, what big things have happened since we live streamed last week. And so, of course, we had this video come out from Melinda about validating your response data with JSON Schema. I've dropped that link in chat already. Great video. We're going to dive in and chat with Melinda a little bit about, what did you have to learn to, come up with a video like this. The other thing is, go check out our Postman blog. We've got so many great Postman blog articles, all the way from the beginner level of what is an API key, what is an endpoint. We take a really strong educational stance at Postman around what do we want everyone to know about using APIs? And it can be as simple as, what is an API key? How do we do authentication? Or what is an API endpoint? It's you're going to hear these terms, what is governance? How do we define those kinds of things? So definitely go check out our blog. We got a lot of neat stuff on there. So this is one that just came out. We've got another one that Joyce, one of our teammates, has made about, if you want to manage your whole Google Cloud infrastructure, you can do all of that with APIs as well. So Joyce puts a lot of really great work into her blog posts. And then I'm a huge productivity fan. So these are just three of many blog posts that we're coming out with on a very regular basis now on the blog. But I'm a big fan of productivity. So I really love this blog post of let's go in and dive in a little bit more. And, I couldn't help it but laugh. It's oh, this one's about JSON. That's great. Because easily 95% or more of the APIs that we use every day are JSON based. And so part of our conversation with Julian today is going to get into, what's the history of JSON? How did it become so popular? We'll talk a little bit about XML and how we transitioned out of, kind of away from that and what the trade-offs are. But definitely go check out our blog. We've got a lot of really great posts coming on here all the time. The other thing is, we've got a session coming up in a couple of weeks. For those that missed the big software release that we did just a couple of weeks ago here in June, we released a lot of updates in Postman. And so we've got a whole unboxing of what have we released new in Q2. And so between April, May, and June, we're on a kind of a regular sort of release cycle now at Postman. Around the middle of the month, we try to do some big release. And so this is a free webinar that you can register for. And you'll get a copy of the Zoom video. We also put these videos up on YouTube as well. But you'll definitely want to check this out, where the team really dives in really deep on a lot of the changes that we've made to the Postman product over the past couple of months. So you'll definitely want to check that out, totally free. And yeah, we've got these webinars happening, once or twice a month now. So that's pretty much it for In Case You Missed It. So let me turn off my screen share here, and we'll kind of go back into sort of conversation mode here a little bit. So let's go over to Melinda. So Melinda, you spend a lot of time working with the open technology team as well as my team, the developer relations team. You're kind of one of our great liaisons between the two. You do a ton of technical writing. How did you get into making the videos and doing the voiceovers and things like that? And then what did you have to learn about JSON and JSON schema in order to make the video that you did? What was kind of the background and the buildup of coming up with that video?
Oh yeah, so the background to that video, I hope this isn't a spoiler, but I know that the JSON Schema folks are working on improving their website and documentation. So I've been helping out with that a little bit, and that was my intro to JSON Schema. I didn't know anything about it before that point. But in this process of working on the documentation, I started to sort of understand what it was and how it worked. And then, because I'm also on developer relations, I was asked to kind of bring some of that knowledge over to the DevRel side and tie it into the product and give something back to our users as well. So that's sort of the context around why we made the video. And then, yeah, I had some of the background from the documentation that I had looked at, and then I had to play around in Postman and figure out, okay, how can I apply this? How does this work in Postman? What does it look like? And there was some trial and error of figuring out, exactly how to get the schema working, and looking for different open source tools to get the schema written, and then testing it out, and then sort of coming up with a story for the Postman user. How is a Postman user going to learn this and implement it, and why is it useful for them? So sort of came up with that narrative and tried to put it in a concise 3-minute video.
Awesome. Well, you do a fantastic job with the videos and the blog posts. I've had you do like kind of the grammatical, sort of text editing on blog posts that I've made for the company as well, and you do a fantastic job. So thank you for the work that you do between our two teams. It's a lot. So really appreciate all that. And I always love like when folks on our team have to like dive in and learn something new. So we really want to like start from let's pretend we know nothing about JSON. We know nothing about JSON schema, and we'll kind of like build up this knowledge kind of as we go and have this conversation with Julian and Melinda today about like, what is JSON? How did all that get started? So let's go back like 20 plus years, building out APIs, back in the early 2000s. A lot of data transfer was happening, over protocols like SOAP, and we were using a lot of XML for modeling that data. And kind of the nice thing about XML is that it's sort of self-structuring, where you can say, here's this data field, it should be this data type, here's the value, and then you had like a validation document that would come with it, that you could not necessarily embed in the XML, but you could reference from the XML to say, if you really want to validate this, here's another document you can download that'll help you validate that what I'm sending you is correct. And that was kind of the nice thing about XML, but it became very bulky and it was very verbose and it was hard to read and like for human eyes to read. I mean, certainly, machines can parse this data really, really quickly, but it was really hard for humans to kind of like look for data in this big wall of text that would come through. And so we wanted something a little bit simpler. And I think that that's where the idea of JSON kind of, really picked up popularity. So Julian, take us back in time and talk a little bit about like, what was that transition like? Like, how did JSON really become like the new standard, and what were some of the trade-offs that we had to make when getting into JSON?
Yeah. My age, let's say, as a developer, is going to betray me a bit when we start talking too much about XML, because as I say, I would say I started as a developer around 15 years ago, and though I've certainly spent my fair share of time with XML in the past 15 years, I can't say that I've ground my teeth having to deal with lots of SOAP APIs, thankfully or otherwise. But JSON, I think, really took over as in the past kind of 15 or so years, JavaScript became more popular. And JSON really really came out of JavaScript. So the JS in JSON is really its roots in sort of taking the notation that JavaScript uses for objects and for other values in JavaScript, and using that to define a file format, to define a way of sending data back and forth. So quite similar to XML, but as you say, much simpler. And for those programmers who are now increasingly using JavaScript, the format was much closer to what they were typing anyhow when they were sharing data through JavaScript. As you say, in the course of trading away the lovely verbose tags like someone in chat, like David in chat has just posted, in exchange for trading away lots of these angle bracket noise, you get something that's a lot easier for human beings to read. Whether or not it's easier for human beings to write is a different question that people like to argue about. But certainly to read, if you read a piece of JavaScript, it makes a lot more sense than trying to read an XML mapping, or in general, trying to read an XML document. And so really what happened was we sort of simplified the amount of characters and the structure that you need in order to send a piece of data back and forth. And so by simplifying that format, you lose a bit of the capabilities that XML has. So XML has things like namespacing, which JSON doesn't have.
How does namespacing?
But in exchange, you get something that's much.
Sorry, how does namespacing help? Like, what is namespacing, and how would that help within like an XML document?
Yeah, you're gonna immediately get right out of my. So
okay.
What it allows you to do essentially is sort of have names that you can. So it's similar to in a programming language. You can sort of use the same name in different ways in different namespaces. In XML there is such a notion, and in JSON there isn't. So if you have some key somewhere, you can't reuse that same key in some other namespace, in some other sort of dotted thing, the way you could in XML. But if you ask me why people want this, I don't know. Although I've certainly seen questions where people say, yeah, namespacing is useful and we want this. But as I say, thankfully I don't have enough experience with XML to really have a strong opinion on whether how much we've lost by not having it.
Right.
But another thing we lost, as you say, is we had to reinvent what it means to schematize the data that we were sending. So in XML, all of these tooling, this tooling was sort of fully thought through. So there is something in XML called XML schemas, and there are things like XSLT, as you say, and all of those. That specification targets XML. So if you have some data that's represented as XML, then you can have some schema that schematizes the XML that you have. And if we're sort of simplifying the data format, we're giving you JSON instead, then we again need a new way of schematizing JSON data. And that's how sort of JSON schema is born.
So one thing as well, just for the history lesson, like 20 odd years ago, we wanted to transfer less data over the internet, and these XML documents would be very large and very dense. And so by switching over to the JSON sort of encoding for our data payloads, it made for a lot less text that we actually had to transfer. Nowadays, though, browsers have a lot of built-in compression tools. If you ever look at your user agent string in a browser, you'll see there's typically like a GZ or a gzip or something like that, which means the browser is actually going to compress and decompress that data before it transfers. So one could argue nowadays is like, do we really have to go to a simpler format when we can do this built-in compression that's just going to compress it all down in a binary format to transfer anyway? But as Julian was saying, it's really about the human readability of like the simplicity of reading through a JSON document. And someone mentioned in chat earlier, like the nice thing about JSON is that it's flexible, but the bad thing about JSON is that it's flexible, right? And unless you have a very rigid structure where you're validating what's going on in your schema, it's nice that you can just kind of send whatever data you want in whatever format you want, but then you need to have some sort of standardization. And that's where, one of the trade-offs that we had to make by going from XML to JSON is now we've got to do all this validation of, is the data we got back actually packaged properly? Did we get the right fields? Are those fields the right data types, or do they kind of look like the right data types? Because JSON doesn't really infer data typing. You can kind of make guesses at it, but Melinda, when you were putting the video together and talking about like validation and so on, I know your video talks a little bit about AJV, which is what does the A stand for again? It's like the JSON validator. I forget what the A stands
It's
for.
another JSON schema
Another JSON
validator.
validator, yeah. Because there have been several over the years. One got deprecated, and so Postman is actually we were using this other one. It had a T in the name. I forget what it was
Yeah, I
called
think it's
now, but
Tiny Validator.
Tiny validator. Yeah, thank you. I'm glad you all remember this stuff. I haven't had nearly enough coffee to recall like all of this stuff. So thank you for helping me through the conversation here. But with AJV, what were some of the things that you had to learn about like validating the schema and like double checking that the schema was right? Like as you're going through that video, Melinda, like what kinds of things sort of came to mind around like building out that testing and getting into that validation?
I'm not sure I follow the question. Sorry.
Oh, I was just like when we talk about like the simplicity of JSON, right? One of the things that we lose is the structure of, you know, what should this payload even look like?
Mhm.
What kind of data types are there? And that's why we've got to do this kind of validation. So this is all like built into Postman now. So maybe can you give us like a 30-second recap of like your video around like the different kinds of things you had to learn about using AJV and going through like some of that schema validation and so on?
Yeah. So I looked at the data. I was using an API where I could just pull random comments, and it was, random like example data. So I looked at the data and I was trying to figure out, what do I want? What patterns do I see in the data? What keys and values do I get from this? And what do I want to validate for? Do I want to make sure that I wanted to validate the data types, like name always needs to be a string and ID number needs to be an integer, etc. So I needed to look at that and look at the data that I was expecting to get and sort of build the schema from there. And yeah, I think that was more or less. Yeah.
Yeah. So again, just one of the trade-offs that we had to make by going to the JSON format was that now we have to do we really should be doing validation on, you know, when we get a payload of data, because like we said at the very beginning of the stream, most of the APIs that we're using nowadays are coming in JSON format. Like the data payloads that we're transferring back and forth tend to be in JSON. It's not the only way of doing it. Someone mentioned over in chat, you know, using protobufs. I'm a huge fan of gRPC myself. I love the protobuf kind of method, but it's also a very rigid sort of schema of you have to use this message. If it doesn't fit into this message, then, you know, the server, the client are just not going to validate that what you're sending is correct. And so it kind of builds that validation in as part of the transit. So you don't have to do the testing. You can, but you don't have to do the testing because gRPC is kind of natively doing that. With XML, you kind of had that structure where, you know, you couldn't really say, you know, I'm going to send this input field in XML as a string, but I'm actually going to send it as a number, because that wouldn't validate just from the scope and the nature of XML itself. But in JSON, we don't really have that. And JSON's also got interesting quirks around, like, you know, you can send numeric data, but if it's a floating point, you know, do you encapsulate it in strings? Because, you know, how does it interpret the dot in the number and things like that? Like, things get a little weird when it comes to JSON and JSON encoding. But JSON encoding is getting faster and faster and faster. You know, a lot of really smart people out there are building really great tools for encoding things incredibly fast in JSON and decoding it, and, you know, back into a data structure of some kind. And so, you know, there's been a lot of work certainly that has gone into this. But, you know, now we kind of have to. I mean, we really should be validating, you know, the JSON data, because we've lost this idea of this is what the structure is supposed to look like. So, Julian, part of what I would love to dive in with you and talk about, like, your background working with JSON schemas and things like that, is like, you know, what are some best practices around getting into like what these schemas are, and really understanding and unpacking a little bit more about like how do we even get started with validating these things, and what kind of best practices should we be following when we're building out JSON payloads and things like that as part of our JSON schema?
Yeah, sounds great. Shall we perhaps dive in?
Sure.
Probably we should stress again the difference between JSON and JSON schema. Maybe I'll start even there by saying JSON schema is a separate specification. Yeah, so it's a separate team that's maintaining something called JSON schema. And as you say, a lot of what the specification is trying to do is to layer functionality on top of JSON. And whilst JSON schema is useful outside of just JSON, I'll talk about that in a minute perhaps as well. Within JSON, or when you deal with an API that's sending JSON back and forth, you're sort of coping with the realities of what it's like to deal with JSON in an API. So for a silly example that I can demonstrate in a minute, in JSON you can't have trailing commas. So if you have an array of numbers, you have the array 1, 2, 3. You can't put a comma at the end. And why someone may or may not want to do that is a nice programming style discussion. But JSON just doesn't have them. You can't put a trailing comma at the end of an array.
For those of us that do a lot of Python programming, having that trailing comma is fantastic. We do it all the time in Python, but we can't do that in JSON for sure.
So frustrating. But yeah, and then people will come legit, or as you say, if you have the number 3.0, you don't know whether when someone gets that, whether they're going to end up with a float or some other generic number type. So JSON schema has to sort of cope with the realities of what JSON itself supports, even if it's trying to help developers like ourselves kind of add some functionality on top for structuring the data as we'd like. We have to, we, including myself in the JSON schema team, have no control over whether JSON has comments, which it doesn't, or supports trailing commas, which it doesn't, or whether it has more data types, which it doesn't. So JSON schema is very much complementary to what JSON is, for better or worse.
Postman now does allow you to put comments in JSON though. If you're doing documentation, if you're writing out some JSON as a saved example, you can put comments in there, but it's not typically part of JSON schema. So JSON schema has been around a while. I'm sure that it has kind of adapted over time as well. Like, what kinds of changes have we seen in JSON schema? Like, if we were to go back to like the first implementation of JSON schema and kind of what we're seeing now, like, would you say that there were like any major shifts along the way, or have they been pretty gradual shifts? Like, what take us through that journey a bit?
Yeah, JSON schema's got quite a history. I'm gonna precisely how many years ago it was, but I can say for sure it was definitely more than 13. I think the first version of JSON schema, as I say, was for sure happened before. So I joined the community when draft 3 of JSON schema came out. So the silly word draft is sort of the word that was used historically to refer to versions of JSON schema. So I joined when version 3 came out. And after that, we had version 4, and then version 5 and 6 and 7. And then JSON schema switched to using date-based formatting. So after version 7 came a version for 2019, which came out in September 2019. So you'll see it called 2019-09. And then the most recent version of JSON schema came out in 2020. So that one you'll see called JSON schema 2020-12. And hopefully without this being a spoiler, the JSON schema team will somewhat shortly, let's say in the next couple of months, be releasing another version of JSON schema. So there's plenty to talk about what's on the JSON schema roadmap. But definitely the answer is yes. A ton has changed over the years. The original author was someone named Chris Zip and Gary Court, if I haven't misremembered either of those two names. I've actually only met the two of them once, maybe twice. But each of those versions, as JSON schema sort of evolved, had a sort of vision for some new keywords, which I'll show off in a minute, And so people came in and added bits of functionality to JSON schema or fixed warts that it had to make it behave a little bit more regularly. And so really JSON schema has been, I think, safe to say, a community effort driven heavily by its authors over the years. So those are people like Austin Wright and Henry Andrews, and more recently, Greg Dennis and Jason DeRosiers and Ben Hutton. So there's a nice kind of group of folks, each of whom have left their mark on the specification. And of course, the community is a large part of kind of modifying or changing that functionality or responding to things that we need over the 15 years or so of its lifetime.
One clarification question, like when we're on DevRel, we're at conferences and things like that, and we're talking to folks or we're doing live streams like this, sometimes we'll get questions about API schema. And when you're talking about JSON schema versus API schema, I think I can see where a lot of folks think that they are the same thing, since so many APIs are using the JSON format. What would you say are like the key sort of differences, or like if you had to explain API schema versus JSON schema, like what would you sort of tell people?
Yeah, so tell me if there's even another thing that I'm unaware of. But when you say API schema, I assume you mean either or both of OpenAPI or AsyncAPI, or in general the notion of a schema for an API? Or is there an actual technology that has named itself API schema at this point?
No, I think it is just the generic term of like, oh, what's your API schema, right? And it's like, well, we're using JSON. Here's the structure of it, right? And so I think,
right.
Not to lead into your answer, but I think like using the term API schema is like saying I drive a car to work, where JSON schema is like I drive, a Toyota Tercel or something, like a very specific, like you're including more specificity. Now even words are hard for me in the morning, but getting more specific about the what kind of API schema you're using. Would that be an accurate way of sort of describing it, where the API schema is like more high level versus JSON schema is like this is a more specific version of an API schema?
Yeah, I would say I definitely agree with that. Although I guess I would also say JSON schema is actually not limited to speaking about APIs at all. In the sense that JSON schema is a way of saying, so let's define the word schema maybe just to make sure. So when people say schema in general, they could be talking about schemas for your database or schemas for requests and responses that come from your API. But the word schema in sort of the world of data tends to mean I'm going to give you some data, and the schema somehow tells you what are the columns or what are the fields or what's the shape
like the structure of the data.
Exactly, the structure of the data. And that doesn't necessarily have to be API related whatsoever. I could have some data on my hard drive, and it's a bunch of files which are written in JSON, and I want to write down a schema for what those files look like, so that someone who tries to use those files later sort of knows what keys all of the files have and what those what the data within it looks like. So there's no API related. There's no API happening here at all, at least in the web API sense. But JSON schema may perhaps still be relevant because you can use it to describe the data that you have. The more common thing certainly is what you say, which is I have an API, or otherwise I'm going to send some data back and forth, and the API schema that I'm going to use, I'm going to choose to use JSON schema to sort of describe what happens when you URL in my API. To sort of summarize, I feel like API is both a more general term, but also not necessarily a strict superset of what JSON schema is really about. So JSON schema is perhaps a kind of schema you might use within your API, but also you could use JSON schema completely unrelated to writing an API in the first place. You just have some JSON or have some data, and you want a schema that sort of describes the fields that data has.
Awesome. Cool. That's great. Thank you.
Yeah.
Okay, so we got into like kind of the history, we got into versioning and so on. Where do you want to go from here?
Yeah, should we look at one? Maybe we should just look at our first schema, I think. Yeah.
All right. Let's pull this down here. I'm just going to pull chat out of the way. If you do have any questions in chat, please do ask in chat, and I'll be able to highlight them on screen. And we'll get Melinda and Julian to answer questions as best we can, kind of as we go through the content here.
Okay, great. Chat is slightly out of view for me, so I assume you'll let me know if there is.
Yeah, I'll take care of that. Yep.
Close this. Amazing. Okay. I'm actually going to start perhaps by not fully explaining at least what you see here on lines 8 and 9, although maybe let's get rid of some white space here. So let me start maybe by again stressing how to think about the difference between JSON and JSON schema. So if someone asks me what JSON is, to me, or when I say to me, by the specification of JSON, it's a string. So JSON is some text somewhere, and that text has a specific format, and the way that format is defined is by the JSON specification. So I have here some JavaScript. By the way, I'm going to apologize in advance. As I say, I'm a Python programmer. So when I do something really silly in JavaScript, you all in the chat can point out my mistakes. But this is a JavaScript string. It has here this contents. So it's got an open curly brace and then sorry, while I fight with highlighting. So an open curly brace and then a double quote, which I'm escaping here just because we're inside a JavaScript string, and then the word type, et cetera, and then this colon here, and then string, and then a closing curly brace, and that's my string. And that's JSON. JSON is that string, which has a sort of specified format. And what it means that it has a specified format is that if I give you that string and you have a JSON parser, then you should be able to take that string and get sort of parse it and get some result. And in JavaScript, you can do that with this JSON.parse JSON parser. So none of this has anything yet on schema, but I just want to stress that if I run this code and if I ignore the stuff on the bottom here for a minute, so I'm just going to run what we have here. And if I open the console, you can see that this console.log line, which is printing out what I get from parsing this JSON string, tells me that I have some JavaScript object. And in particular, I have a JavaScript object that has a property called type and a value of that property called string. So I took some string here, which is my JSON, and I parsed it. And what parsing it did was give me some JavaScript object. And that's true in any language. If you have a JSON parser, you're going to take some string, you're going to parse it, and you're going to get some object in that language. So in Python, if I use a JSON parser, I get the result of parsing this JSON string into a Python dictionary. So what can I do once I've parsed this JSON? This happens to be a JSON schema. It's quite a simple one. In particular, if I type it out without the quotes, it's this schema here, which is basically a schema which you can imagine says that data is supposed to be a string. And I can use this schema to make sure that something that I'm validating is a string. If it is a string, it will pass. If it's not a string, it's going to fail. Now, the way I use a JSON schema is by taking an implementation of JSON schema, and Postman has one built in called AJV. So I'm going to use that without fully explaining what this next line is here. We'll come back to that later, perhaps. But if I just I'm going to create a Postman test here. So let's call this test strings are strings, because we're going to just validate that. We're going to validate that if I take this schema that I started with. So here's my schema. Remember, it's just type string. And if I pass in the string foo in JavaScript, and if I run this, and if I haven't made any mistake, then here on the test results tab, you can see we have a pass for this first case. I'm going to comment out my second one just so it doesn't bother us here. Excuse me. And let's make this smaller. Okay, so you can see here this first test where we're just asserting, let's move this schema down here, where we're just asserting that some string is a string, passes. If for whatever reason we don't have a string, so if I pass in the number 37, if I run this now, what have I done wrong here? We're already having a failure. So let's try this again. Oh, I didn't actually make any assertion. So here's the live coding. Here's the live coding take two. So in Postman, if we have some expectation, I need to actually say what I expect this to be. So in this case, I expect this to be false. And now that should fail. Well, it should pass, but if I expected it to be true, then now that fails. Okay, let me explain that again with getting this console out of here. So this is sort of our first example of taking a schema, a very simple one that just says, I expect my data to be a string. And when you try and validate the number 37, then you're going to get, nope, that's not a string. And so your test is going to fail. But if you validate a string like the string foo, then that's going to pass.
So Julian, just a quick clarification on the schema that you've entered here, where you have type string. Is this sort of structure and the use of words here, like, are you saying the data type of this needs to be a string, or could you put in like hello world and check for the number 37? Like, does the word type and the word string, like, does that have relevance to what you're passing in as the second parameter here, where you're doing like the 37 and the foo?
Yeah, very good question, obviously. So let me name these variables just so that it's quite clear what these are. So this is my schema here. I'm going to move this out here. This is my data. And I'm going to run this again. It will do the exact same thing, I hope, other than that I forgot a semicolon.
JavaScript is pretty forgiving about the semicolons nowadays.
Oh, is it good? I'm glad to hear that. So to answer your question, JSON schema, the specification, is defining this keyword called type. And that's a keyword that JSON schema says you can use if you want to assert about the type of a value, whether it's string here, which JSON schema also defines, or there are a whole lot of other types that you can assert against. So you can say, is something an integer? You can say, is something an array? You can say, is something an object? I'll show some other examples that use these other types instead. But essentially, the type keyword and the value that it takes are both defined by JSON schema.
Okay. So it is saying, based on the data that I'm actually going to be parsing, I expect that it matches this actual data type. So the words that you've chosen here, like type object and type string, those are specific things as far as like what the validator is looking for, as far as the overall structure. Okay.
Great. Yeah, exactly right. I actually, let's see, in the spirit of breaking things, if we type something that I know is not a valid type, so something else, I expect AJV should error here, but let's find out. So if we send this, yeah, so you can see here, if I type something else here, which is not one of JSON schema's 7 valid types, AJV on the bottom here is saying schema is invalid. So this thing is invalid. Data.type should be equal to one of the allowed values. And essentially, something else is not one of the types that JSON schema has. So there's a fixed list of 7 possible types. And those 7 possible types correspond to the 7 types of values that exist in JSON. So yeah, both of these, both the key and the value here are something that JSON schema is defining. So I'm going to go back to this being string. Our test should go back to passing. Yeah, good.
Okay. Can AJV only test one field at a time, or can we give it like a more nested structure of, this thing is an object, and inside of that object we should see a string and a number? Like, can that schema be more complex than just this one thing that I'm looking at needs to be a single data type?
Amazing. So of course, if we could only validate one, let's call them atomic values like strings and numbers, we wouldn't get anywhere, because of course data is more complicated than that, and we want to package together fields and package together multiple elements. So yeah, that's a perfect segue. Let's maybe validate arrays of integers. So I want to now write a schema that that validates that all of its elements are integers and none of them are not integers. So perhaps people can guess at the first bit of that. I'm going to copy paste this test here. So lists of integers, let's call them arrays of integers, because that's the terminology used in JavaScript and in JSON. Arrays of valid integers, or arrays of integers are valid. Okay, so the first bit of this uses the keyword that we know already. So the type keyword, and I'm going to give us some space here to evolve our schema. The type keyword is what we're going to use to say that I want an array. So that's just type array. And then now we need a new keyword to deal with how do we say that all of the elements of the array are supposed to be integers. And so in JSON schema, that's a keyword called items, which is a keyword that applies to any array. So again, this is JSON schema saying, you should know there's a thing called items. And what that keyword means is that what you give to items, which I'm going to type out here in a minute to replace the ... this needs to apply to all of the items in the array. If any of the items don't satisfy this schema, and it's going to be a schema, then validation is going to fail. Excuse me, I have to sneeze, perhaps? No. Okay. So this is how you say, I have an array, and all of the items of the array are supposed to be integers. So the items keyword takes a schema. So the value that goes in the items keyword is another schema. And that schema is going to be individually applied to all the items in my array. And as I say, if any of them don't meet the schema, then you're going to get a failure. So let's start perhaps with an invalid example. And folks in the chat, feel free to speak up if anything I say doesn't make sense to you. But if we start with an array that is not an array of integers, then hopefully our test here is going to fail. So let's just make sure that I haven't made any mistakes here. And sure enough, we get an error because this array does not, in fact, contain an array of integers. So if I change this now to 137, now our test passes.
If you make one of those a float value, will it also fail the validation, or is it kind of looking at numeric values a little more generically?
Yeah, that's a good question. Well, let's try, and then I'll explain what's happening. So the number 3.0 does pass. The number 4.32, however, makes our test fail. So there's a bit of technicality here, which I'll try and explain quickly. As you mentioned previously, JSON, the format, basically defines a number type. It doesn't really differentiate between floats and integers. It just sort of requires that languages have some form of number type. JSON schema, when you write type integer, knows that you mean a thing that has a zero fractional part. So that's why 3.0 is okay, but 4.32 is not. So that's the short answer, is that if I want 4.32 to be okay, I change this to number, and then now this works.
Gotcha. Okay. Hey, Julian, can you check your microphone real quick? We're getting some crackling coming through the mic. I don't know if you're working off your Bluetooth headset. Maybe the battery's getting a little bit low, but it's crackling a little bit as it's coming through. Melinda, while Julian's checking that, did you have to go learn, about all these like schema setups and stuff when you were making that video? Like what kinds of things were you sort of building into your schemas and the assertion tests and stuff that you put into that video?
Yeah. So when I took the easy way to build my schema. I did not build it by hand. I used a open source tool. I don't remember exactly which one I used. There's a handful of them out there, but I basically took a few examples of the data that I was getting from this endpoint and asked a tool to build the schema for me based on what was in the data. So I looked at that. I tweaked it a little bit. But I did something similar here where I put the schema. I did not have it inside of a test, though. So I'm interested to hear how the different way that we could set it up. Because right now, the schema is embedded within the test, and I had the schema outside of the test.
Okay.
But I did a similar thing where I had some things were strings, some things were, I think I only had integers. And strings, but another thing that I learned was one of the fields that I was validating was an email address. So that one was a string type, but then there was another, I was able to specify the email format within that string type.
Oh, interesting. So you can get even more specific than just a string. Like this string needs to be a URL, or this string needs to be an email, or things like that. Looks like we've lost Julian. There he is. Just came back. Hey, Julian, welcome back.
Thank you. Hopefully the mic is better.
Yep. Yeah, it sounds great.
Perfect.
Yeah, we were just chatting a little bit about Melinda's video and some of the stuff that Melinda was learning about validation and so on. And Melinda mentioned, Melinda, correct me if I'm wrong on this, you were building the schema variable outside of the test, or you didn't do any of your work inside of test? You just put everything in the test block?
For mine, they were separate. I built the schema first, and then I added the test below it. So that's a separate step. Yeah.
Gotcha. Julian, do you want to reshare your screen as well? We can get your Postman back up and take a look at what you're building there. There we go.
Yeah, that's a good point.
And again, if you're in chat, you got questions about any of this stuff, about JSON schema or the validations and things like that, please do ask in chat. That's why we got folks like Melinda and Julian on the stream here. So feel free to ask questions as we go.
Yeah, it's a good point, of course, that I'm sort of showing things off here as if you yourself are putting together a schema for some data that you're trying to validate, or some data that you yourself have somewhere. But often someone will give you a schema, either because it's an API schema and the person who wrote the API is giving you a schema for the request that they have, or because you got that schema somewhere because someone else wrote it, and then you're just gonna sort of use that schema with the data that you're validating. So here, as I say, just for the purposes of explaining the keywords in JSON schema, we're kind of building those up one by one, but that's not necessarily going to be the case always. Sometimes you'll just use someone else's schema. I'll drop a link to Schema Store later, which is a good thing to be aware of for just a big library of schemas you can use. Should we jump back in here?
Yeah, let's do it.
Cool. So let's do. So we've done simple values like strings and numbers. We've done arrays. Let's get the next obvious one out of the way, which is perhaps objects. So when I say object, what I mean is what the word object means in JavaScript and in JSON. So before we name our test here, I'm going to perhaps get rid of the description. In JavaScript, this is an object. It's got a key called foo and a value 12, and JavaScript will map the key foo to the value 12. In JSON, there, of course, also are objects. So there are mappings between unique keys and values. And so you're often going to have data that's represented or serialized as a sequence of keys and values. They can, of course, be nested. So I can have here an object with another object inside. So let's pick something more interesting, perhaps, than just dummy data here. Maybe we have an object that represents a contact in an address book or something. So let's maybe do contact equals, and then maybe we have a name. So I'll do myself here. And then perhaps we have a social handle. And then perhaps the social handle is a platform. So I'm going to put Mastodon here, and then a username. And then I'm going to put my username, which you'll also see below my image for the shameless plug. Okay, so that's maybe our data. Let me reformat it so it's a bit easier to read. And so we want some way of actually specifying what data points like this look like. And so you can see here, we're probably going to want to say that we have a name. From a data modeling perspective, if you're writing an address book, you probably want the name to be required. So somehow we want to be able to say there needs to be a name property in this object, and then perhaps optionally we want this social handle, which gives you some information about the contact's social media. So how do we actually schematize? How do we write a schema for an object that looks like this? So let's start with the easy part, which is that instead of the items keyword here, so let's say contacts with names and social handles are valid contacts. So I'm going to write a test here for a valid contact like the one I have above here. Let's actually move it within my test. Instead of this data field here, we'll put our contact. And I know there's some better indentation support in Postman than what I'm using, so you'll forgive me all for doing this the old-fashioned way. What can I do? I'm a craggedy old Vim user who doesn't know all of the fun tricks. So teach them to me. Okay, so let's write a schema for this. So first of all, if we just reuse the schema we started with, I should hope that we'll get a failure because our data is not an array. So let's just run this just to see it fail. And if I scroll down here, you can see our test failed. So let's start fixing that. Instead of saying type array, I'm going to say type object, because our contacts are JavaScript objects. And the keyword that we need is called properties in JSON schema. So this is a keyword that basically allows you to define what the properties contained in an object are supposed to look like. And so our contact here has two properties. One of them is called name, and we'll fill in some stuff about name. And the other one is called social handle, and we'll fill in some stuff about that as well. So I'll explain this in more detail in a second, but let's just make sure that our test now passes. And it does. So here's my test on the bottom. So that passes. Was someone going to jump in?
We did have one question actually. And I think you'll be the best one to handle this. Can a JSON schema be used to validate data from a Python dictionary? Can it identify and assert results based on the structure of the dictionary? It sounds like you're kind of walking us through that right now. Like you're specifying, with this structure, I'm expecting to see these fields, and these fields are going to be particular data types. I'm going to have a follow-up question. If this test passes, I've got kind of a follow-up that I'd like you to try, but I'll let you keep going with the name and the social handle that you have going here.
Yeah, I'll say one thing about the Python question, which is JSON defines an object, which is a mapping between keys and values. That concept has different names in different programming languages. So in JavaScript, that notion happens to also be called an object, and that's what we're doing here. So I sort of skipped over this when we transitioned talking about JSON, but what I'm validating here is really a JavaScript object. The equivalent of a JavaScript object is a Python dictionary. So the answer to David to your question is yes. And the reason why is because JSON schema can validate JSON objects. And in JavaScript, a JSON object becomes a JavaScript object. In Python, a JSON object generally becomes a Python dictionary. But JSON schema can deal with either of those because those are the equivalent notion of a JSON object. Okay, so let's jump back here. Hopefully that makes sense. If not, David, feel free to let us know what you had in mind. Okay, so let's fill this in here. I'll demonstrate perhaps one thing wrong with our schema by, let's get rid of my name here and replace it with the number 37. And then of course my test will still pass. And the reason it still passes is because we haven't really said anything about what the name property is supposed to look like. So of course we want name to be a string. And so now that I have this schema here saying my object is supposed to have a property called name, which is a string. If I run that, now this example still passes. Why does it still pass? Because I'm validating data instead of contact. So that's a name error for me. There we go. Okay. So I was passing the wrong data into my validation function. So of course, if you're not validating the right thing, your validation is not going to help you. So now that we're validating this contact, and now that name doesn't meet this schema, it's not a string. Let's make this a little smaller, perhaps. Now we can go back to our actual name here. Excuse me. And our test will go back to passing, I hope. Good. Okay. And now let's deal with social handle. So social handle here is supposed to be a nested object. So again, perhaps I'll go a little bit faster now. But feel free to ask questions, folks, if you're not following. But social handle is itself going to be an object. So I'm writing another schema here saying social handle is an object, and it also has properties. So let's write out those properties. I use two of them here, platform and username. Let's say nothing about platform for a minute, but then about username, I'm going to say type string again, because our username is supposed to be a string. And if I, again, validate this schema, which I realize is now slightly off the page, but hopefully you can see it now. You can see our test passes. So let's talk about platform for 1 second. Hypothetically speaking, if we're modeling our contacts, we might want to say that the platform that someone's social media handle is on is one of a few known social media platforms. So perhaps we might want to support Twitter and Mastodon and Facebook and YouTube and LinkedIn, right? So we're going to have 5 platforms that we support, and I want this key in my schema to be one of those 5 possible values. So it needs to either be. So how do we make this? Either YouTube, LinkedIn, Mastodon, Twitter, or Facebook.
So you can actually get more specific than just the data type. You can say the string also has to be one of these possible choices.
That's exactly right. Right. So I want to be able to say
Okay.
it should be one of these possible choices. And here is really where JSON schema becomes more interesting than just a way of annotating types. Here, what I'm trying to say here is not just the type of this field. I'm trying to say, no, it's got to be one of these 5. And if it's not, then that's not the right shape of my data. Similar to how in a database, you should be able to say this column is an enum of one of these 5 values. And sure enough, in JSON schema, it's called exactly that. So again, I'm introducing a new keyword here in JSON schema, and that keyword is called enum. And so I can say that platform is an enum, and it needs to either be, I'm going to copy paste this so I don't, well, all right, I'll type it. YouTube, LinkedIn, Mastodon, Twitter, Facebook. And if I haven't made any syntax errors, which I don't think I have, maybe I'll pause and ask someone, does anyone want to guess what's going to happen if I run this example again? I'm going to sort of scroll down a bit here.
I'm going to hope this fails.
Yeah, that's a good guess. Anyone see why it fails?
Is it case sensitive when it's doing that match on the enum?
Yeah, exactly. So enum is a strict case matching. It just checks the values with each other.
Can we tell the enum to be case insensitive? So if they do type Mastodon, like in some mixed case or weird case, that it would still validate okay? Or would you have to go in and put like all the different variations of that as part of the enum?
Yeah, the short answer is no. So enum you can't tell to be case insensitive. However, you can abandon the notion of enum entirely if you want to support all sorts of different cases. You can use a regular expression, and of course, in a regular expression, you can make that case insensitive. Or so I can show off perhaps the pattern keyword in a minute, which is how you would do this as a regular expression. But yeah, for now, this is failing.
We could spend a whole 90-minute session just on what's a regular expression and diving in on that. I don't think we'll go down that rabbit hole today.
Cool. Yeah. In fact, it may take 90 minutes just writing the regular expression. So yeah, that's quite good.
I would just get ChatGPT to write it for me nowadays. So.
I like it. Okay, so you can see this passes now. Because now I actually changed the data now to actually have capital M. And now this test on the bottom here says pass.
So what's interesting about this, though, if you scroll up to the schema, sorry. So earlier for the platform, we actually didn't specify anything at all. We just had empty curly braces until you added the enum. So with the schema validator, you don't have to specify the data type, but you are saying, like, I expect this field to be here. What would happen if in the data, if we added another field just in the data, not in the schema? So if you scroll down a little bit to where you have your Mastodon handle, what if after username we added a third key, or just some other piece of data that we don't have in the schema? Is this still going to validate properly? Yeah. Because the schema that we're mapping, we're saying, I expect there to be a name, I expect there to be a social handle, I expect social handle to have attributes called platform and username. But if we have something else in the actual data payload that's not part of the named schema, does that still pass? Like, is it only validating the fields that actually match here?
Yeah, so let's
don't put in your real phone number.
Yeah. Sure. Everyone feel free to call me. Actually, I shouldn't say that. So let's put in a phone number here with this extra field. And if I run this, you can see this still passes. So the answer to the question is, based on what we've done so far, this schema does not say that your data is not allowed to have extra properties. At the minute, it's allowed to have extra properties. And because we haven't said anything about what those extra properties are supposed to look like, anything is perfectly acceptable there. So I could have phone number, and the number 37, that will validate fine. I could have phone number and some object.
Because it's not looking for that field at all. So it doesn't
Correct.
matter what you set that value to, or whether that's another whole like nested object. Like the schema validator doesn't care because we haven't told it to look for that specific field.
Correct. Yeah, exactly right. That's the way JSON schema behaves by default. Whether this is the right thing for you when you're, so I'm going to show, I'll show you, well, let me show you first how you change that behavior. So hopefully folks can guess that the answer is going to be another keyword in JSON schema. It's going to be a keyword which basically says, and these are all the properties, any other properties are not allowed. So hopefully not too surprisingly, that keyword is called additional properties. And so if I say additional properties false, and I'm going to come back and explain what this false here means in just a second. But now this means I've listed all the properties that belong in my object and there are no other ones. And so if I run this again, now you can see that we've failed here.
Does that keyword cascade recursively through any other object, or do you have to specify that for each object? Like, would we have to specify that as part of the social handle object as well? Or doing it at the top level, does that sort of recursively go through any object that you define?
It does not, yeah. So there's no recursion whatsoever.
Oh,
so if you want, if you want that to apply, basically this applies to the level of schema that you're at. So this is basically saying here, at the top level of my schema, so name, phone number, social handle, this is saying no other properties here. But it has nothing to say about what happens in here. This thing still allows, so if I move this here, if I just move our phone number down here, this is going to be fine.
Interesting. Okay. Huh.
So of course the fix, quote unquote, is the same. If I want no more properties in social handle, then I go down here and I say additional properties false.
So you need to specify that for each object then?
Yeah, I mean, so you often will. I would say, you know, it's often the case when you're specifying data that you do want to make sure that your schema covers the entirety of the fields that your data has. But not always. Sometimes you write a schema and you're perfectly okay with extra fields being in there because of things like forward compatibility, meaning someone may come along and add a new field and you don't want all the validation that you have to start failing just because someone added a new field. And so whether or not you want to include this additional properties false or not really depends on what you want to happen in that case. Do you know for a fact that these are the fields your data has and no data point has any extra ones? If so, you can use additional properties false. If you don't know that, or if you're perfect, if nothing is going to break, if your data has an extra field in it, then you may be okay without it.
Right. So as long as you're defining the fields, it's going to validate those fields. And if you want to validate that these are the only fields that I'm getting in that data, then you would specify that extra flag.
Exactly. Yeah, because often you're writing this schema and you're doing this validation to make sure that some other processing that you're about to do is going to work the way you expect. And if in that further, so for example, if I have my address book and then I want to validate this contact, and then immediately once I'm done validating this contact, then I'm going to go want to ping this person on the social media platform that's in the contact. Well, that operation is not necessarily going to go wrong if there's some other field in the contact that's not one of the ones that I listed in the schema. That won't affect me pulling out the social media data from the contact. And so in certain cases, you actually don't necessarily need to make sure that your data has no extra properties, but in some you do.
Okay. Cool. We got a couple of minutes to kind of wrap up here. We like to reserve a couple of minutes at the end for community shoutouts. So we got about 10 minutes left. What are some of your other like favorite tips and tricks around like building out these schemas and doing the validations and things like that? Show us maybe one or two more. Yeah.
So there was no chance to cover all of the keywords that exist in JSON schema. So I'm going to pick essentially one or two others. One of them, let's talk about a good example of combining schemas together. So let me again copy this test, or at least this portion of the test. So sometimes you have multiple possible schemas. So let's again start with my schema example here. Let's say for whatever reason, in one place I have a schema that I want to use for names, and in another place I have a schema that I want to use for a social handle. So for example, let's do, I'm going to type this out quite quick. Here's my schema for name again. It's properties, properties, name, type string, and then const social schema properties, social handle, type object. So here I have two schemas here. Let's put them on one line so it's easier to see. This first schema says I want an object that has a property called name, which should be a string. And the second one says I want an object that has a, or if a thing is an object, then it needs to have a property called, or social handle should be an object. So sorry, I'm dancing around a little bit there.
No, it's okay.
For reasons I'll explain in a minute. But how do I apply both of these schemas to my contact? So I want to combine the two together and say, well, my contact is supposed to satisfy both the name schema and the social schema. And the answer in JSON schema is that we have these keywords called applicator keywords. The name is less important. The point is, I want to be able to say I have two schemas and my data is supposed to satisfy both of them. And the way you do that is you say all of, which means my data needs to satisfy all of the following schemas. So I'm going to put name schema and social schema.
You just make an array of those.
Correct. Huh. Yeah. So this is a JSON schema that says any data needs to be valid both against this schema and against this one. And if I run this again, if I haven't made any mistakes, context with multiple schemas, then yeah, now we have a passing test here.
As a programmer, I see all of, and I immediately think, is there an any of? Like, could I say like, it should match like any of these?
Yeah.
Okay.
So
it's like
so there is an any of. Exactly. Any of is like or. There's actually three. So all of means you have to satisfy all of them. As you say, any of means you have to satisfy any of them.
None of?
There is a none of, although it's not spelled none of. So there's not, okay. which you can combine with all of to get none of. So if I say not all of, right, which way? Not any of would be none of.
Yeah. Interesting. That's cool. I love like nerding out on just trying to explore like, oh, I wonder what this would do.
Oh yeah.
That's cool.
Oh yeah. And there's also one of. One of is quite common. One of is like any of, but so here if I just say one of, this is like any of, but it means that the data has to be valid against exactly one. So if it's not valid against any, then it's going to fail. If it's valid against both, it's also going to fail. And that's quite common if folks know what a union type is, or basically it's a way of saying like my data is either this or this or this, but it's not supposed to be all of them mixed together.
Interesting. Wow, that's kind of cool. Because maybe you've got a schema for Twitter and a schema for Mastodon and a schema for Facebook, and you're saying I expect the social handle to be one of these, right?
Exactly. Yeah, and sometimes when folks model data, they do it this way where your key is actually Mastodon and your value is the username. So if I just quickly mock this up, so you could imagine a contact having this or this, and if you wanted to exclude the possibility of having multiple ones, then you're going to end up using the one of keyword because you don't want someone to have both a Mastodon key in there and the Twitter key in there, perhaps.
That's pretty cool. Can you also nest the like the one of and the any ofs as well? Like I could say like my schema has to include name and any of, you know, Mastodon, Twitter, Facebook. I'm just asking, like, you know, just generally speaking, is that a possibility as well? That's cool.
Yeah, it's a good question. In general, all the keywords in JSON schema are independent, I would say. So in other words, once you've learned a keyword, you can use that alongside other keywords. So yes, you certainly can say, my thing is an object. It has a property called name. So it's the properties keyword again, name, type string. And you can still have this one of keyword here, which adds some extra conditions. So for example, maybe it's this social schema, or maybe it's, you know, schema 37, which is some schema I haven't written out here, but this will apply both this, it will apply both the type keyword, making sure your data is an object, as well as checking that the name keyword is a string. And then it will also check that that the entire object satisfies one of these two sub schemas, if that makes sense.
Yeah, that's pretty cool. And Melinda, one of the things that you were talking about in your video was getting even more specific with the type of string. So in Mastodon, for example, the Mastodon username actually looks like an email address. So that social handle, we could get, so if you go back to like test number 3, I think, where you've got
this one,
the type string for username on line 36, you can actually add like type email on the end of this as well. So you're not just saying, I expect this to be a string, but you're saying, I expect the string to match, you know, this extra type. In this case, we could probably put in like type email in here as a second property.
Format is the key name.
Or format? Okay.
Yeah, so it is a keyword called format. And there are some tricks to be aware of with the format keyword. First of all, I'll point out that, for example, Mastodon usernames.
Oh, it starts with an at. Yeah, you're right. Yeah.
You're right. But you're right. There is this keyword called format, which you can use for being even more specific about what the exact format of your string looks like. And there is one for email, which you can use. And there are other formats as well. Like if you have someone's web page, you can say format URI, and that means this is supposed to be a URL. So yeah, there's this keyword called format, which is also useful.
That's cool. It's interesting that they would use a keyword of URI if you're putting in a whole URL, because URI is typically just the path of the URL, not including the domain and the protocol and so on.
That's a URI reference, and there is a format called URI reference as well.
Okay.
Just the term URI by itself is almost interchangeable with URL. It just means that if you go to that, if you put that in an address bar of your browser, that doesn't mean that something loads.
I got you.
So there's this funny,
Yeah, it's the pedantic.
Exactly, it's totally pedantic, completely pedantic.
Right. That's great. Cool. All right. I think we could probably start to wrap up. So thank you for sharing those tips and tricks. And Melinda, thank you for the video you put together as well. It was a really great condensed version of everything that Julian just kind of walked us through as well. Julian went into way more detail. So it was great getting to have a conversation with both of you. We like to end our stream with community shout outs, anything going on. So Melinda, let's start with you. Any community shout outs, anything you want to kind of highlight, spotlight, anything coming up? Any fun events you're going to, anything along those lines?
Nothing jumps out. I was just at Tech Summit last week, and that was great, but that's already passed. No, nothing off the top of my head.
Else? All right. Julian, how about yourself? Anybody, anyone within the JSON schema community that you want to shout out, or any kind of, you mentioned there might be like an upcoming change, like what should we be watching out for there? Do you have like a URL that we can go like watch what's happening, you know, with the JSON schema and things like that?
Yes. So is this going to let me stick it in chat?
There is a private chat in Restream down the bottom left corner. You'll see a private chat. If you just want to drop it in there, I can put it in for everyone else. Cool. I'll drop that in chat for everybody. So tell us about this JSON schema Slack group.
Yeah, I'm going to plug both of those links. So the first one is
Okay.
the official community JSON schema Slack, where there are tons of people who are knowledgeable about JSON schema as a specification, who can help you, whether it's designing your schema or figuring out why a JSON schema doesn't do what you're expecting it to, or whether you're using an implementation of JSON schema. Implementers like myself are there. You can ask us advice on how to use the implementation. So that's that first link, that jasonschema.slack.com. And because I always forget, I think you may need to, if you're not already invited to that Slack, you're going to want to go to the JSON schema webpage, which will be the third link that you'll see in a minute, that I just pasted in the chat. So that's the jasonschema.org link that just came through. That's the official JSON schema website. And if you go to that, you'll see a button that will get you into the Slack. So come join us and say hello. And then just very quickly, the second link there is where JSON schema evolves as an open source project. So if you want to get involved, if you want to see what we're discussing, if you want to learn more about the upcoming specification that that will be released in a few months, all those discussions happen in the GitHub link. So you can come participate, ask questions, or if you have ideas for how to evolve the spec, drop them there or come discuss them in Slack. So that's where development of JSON schema happens. So yeah, come say hello.
Julian, you also mentioned like some sort of store, like a JSON store of like all different kinds of JSON schemas. Do you have a link for that and something you can describe briefly about like, you know, what those different schemas are, why we might use them?
I did. Thank you for the reminder. So that link is now in chat as well. It will come through for you all in a couple of moments. Schema store is not something developed by us, the JSON schema team. That's something developed by a GitHub organization, which you can find by visiting that website. It's people who are pooling together JSON schemas for lots and lots and lots of different things. You can see that website, I think, has thousands at this point. Less so about modeling data, so it doesn't have like, here's a schema for a contact. More when you're writing a GitHub action, if folks know what a GitHub action workflow looks like, then Schema Store will have a way of having a schema for the file that you're writing, and your editor, if you use VS Code or NeoVim or Emacs or any of those editors, your editor will help you write those files by making use of these JSON schemas. So it's super useful. I personally use these schemas many times a day. Every time I'm writing a config file or a GitHub action or something of the like, my editor is configured to automatically be using the relevant schema from Schema Store. So it's super useful, and you should check them out as well. They definitely deserve the shout out.
Yeah, that's a really cool sort of setup, and it's searchable as well. You can go in and I saw an interesting one. It was like something about airplanes or something. There's like an airplane task schema or something. I'm sure the airplane's like an actual technology and not like, oh, here's something that an actual like airplane does. But yeah, these are like very well documented for sure. And it's cool that we can like just grab these. They're all open source, so you can just grab these schemas and start building off of them and start doing your validations and so on. That's great. Cool. For me, my shout out's going to be the Intergalactic that we have coming up in a couple of weeks. I love the unboxing where we go through and we kind of demo, like, here's what we've been adding to the Postman product. So definitely go register for that. It'll be free to register. Let me go grab that link again real quick, and I'll drop that in chat for everyone if I can find that browser window. It's here somewhere. There it is. Yep. So let me go grab this, and I'll drop this in chat for everyone as well. So it's free to register. And if you do register, then we will send you the Zoom video afterwards, and then we post the video up on YouTube. So if you want to kind of watch the team unbox it, Arlemi and Pooja are going to be doing this session, and they're basically going to be walking through everything that we've added into Postman over the past 3 months in April, May, and June releases. What were all the new features and so on. They're basically just going to spend a whole hour just going through, like, we did this, and like demonstrate how all those things are done inside of Postman. So definitely go check that out. Come hang out with us on that. Ask lots of questions. We'd love taking questions on those sessions. And yeah, we do a live stream every week. So come back and hang out with us every Thursday. Next week, I'm going to have a guest on the stream. We're still working through what that topic is going to be for next week, but should be really, really great. The person that I'm going to have on the stream is a very dynamic public speaker. Loves doing a lot of really interesting things with web technologies and stuff like that. So we'll be sharing some of their videos and so on through the session as well. So that's pretty much it for us for the week. So thanks everybody for hanging out. Julian and Melinda, thank you so much for your time and walking us through this stuff and sharing your knowledge. I'm a big fan of just people sharing knowledge with one another. And I think going in and like diving into the history on this and seeing like, how can we get into validating these things? So definitely go check out Melinda's video. It'll give you like a really good quick start, and then lots of tips and tricks shared today with all this. So thanks again for hanging out with us. Thanks again, folks, for coming by and sharing knowledge with us. And we'll catch everybody next week on the stream. All right. Take care, everyone. Cheers. See you next time.